Um, all right, everyone. So today we are going to be doing a very important Leetcode problem. This is number of island, and there has been multiple versions of it asked in many major companies like Google, Microsoft, and so on. And I solved this question a long time ago, and now I'm trying to solve it. It did take me a little while to get how I'll proceed with this and all. So I have written some basic comments, but let's start with the problems and what the problem states. Okay, so basically we are given an m cross n matrix, right? A grid where we have ones and zeros. Ones mean land and zero means water, and we have to return the total number of island present. So what does an island mean? An island is surrounded by water, is formed by connecting edges, and we can assume that outside of this is water, right? So let's just look at an example right here. So the output is 1. That means if you can see, we have these ones, right? And then this one is also included, then these twos, and then these two. If you see, this all will be considered as a single land. There is not another land that has been covered from all side of water. If there was a one, let's say here, then that our answer would be 2, right? So basically that's our question, right? So first of all, why is this a graph question, right? That's how do you think that you have to traverse by the graph? Why do we think of it as a graph question? Is if you see, if we start traversing from a land, let's say we start going into the search space from land, let's say 1. So we have two choices, move down, move left, move up, move right, move down, move up, move left, right? But since this is the first node, we can't move up and left, we'll move right. Then again we have two choices, down or right. So we can move right. Then again we have two choices, right and down. Since down is 0, we don't want to go to the water. We just want to see what other lands are connected to this particular, so we can join, kind of keep track of how many ones are joined to make a singular land. So we go on 1, then we have right and down. Since right is 0, we don't go right, we go 1. Then we say, hey, all of this is traverse. Then it has two choices, right? We went to this choice, the right one. Let's go to the down one. We have it down, then again we have down, then left, then this goes up, and it's completed. Since it's already been traversed, we won't go there again, and we know we got a one land that has been surrounded all side by water. So basically that's my understanding. So as I've written here, we traverse starting from a land and keep traversing all the lands connected to it, and will mark them as visited. Then the total number of unique traversal starting from a land, that is 1, will be our answer. Okay, so let's get on with the basic base cases. So if grid length is 0, we just want to say, hey, you don't have any lands, return 0. Otherwise, what we'll do is, for int, will go inside our grid matrix, right? Grid dot length I plus plus j equal to 0, right? Go into rows and columns, right? And then we're going to say, hey, if the element that I'm at, say grid I comma j, if and only if it's equal to 1, right, then only we are going to traverse, hey, do DFS, right? And if that's the case, let's maintain a variable here, say int land count, and we'll initialize it to 0, right? and we'll say, hey, whatever the result our DFS returns, we'll say land count equal to land count plus that DFS call. Let's try to build that DFS call and then we'll see, right? And after that, of course, we will return our land count. Now here comes the important part. So basically we'll have a function which will return the integer, and we say DFS, and what will it accept? Of course it will accept a char of length is right, and it will accept a start index, right? So I comma j, so let's say I comma j, right, from where we have to start our DFS, right? So let's get on with the base condition. If and if in any case, if I is less than 0, since we for every element we are looking into 4 possibilities, right? Top, right, down, bottom. So if just for the sake of explaining, for this element, if you go on top, that is out of bounds, right? So we'll have to check that in our base condition. If I is less than 0 or I is greater than or equal to grid.length, right? Or if j is less than 0, who knows? Or j is greater than or equal to length, the column length, right? In this case we'll say, hey, we don't have an island, let's just return 0, right? In any case, we want to say, hey, we are at an element and we found that it's not out of bounds and it is equal to 1, since we are only giving when it's equal to 1, right? So what are we going to do? We say, hey, grid I j, let's mark it as visited. Instead of making a visited array, we will mark it as 0, because we don't visit a 0th element, right? So let's mark it as 0. Then we'll say, hey, visit all 4 direction, right? Visit all visit all 4 directions. So we'll say, hey, DFS, right? We have our grid. Let's start from the left, or we can say top, right, down, left, right? That will be good too. So if we go on to top, we say, hey, above row, right? But the same column. Then right, then we are going into right, so we say, hey, the row remains same but the column increases by 1. Then we say, hey, we want to visit the down, then the row increments but the column remains the same. Then we say, hey, we want to go to left, down, left. Then here in this case the row remains the same but the column decrements, right? And after we have traversed every of it, we'll just traverse, we'll mark it as 0, right? All right, here one more condition is there, right? Let me add it later and I'll tell you why I'm adding it. So after that we say, hey, we have visited all of its neighboring. then we can return 1. Hey, we found an island. If we have visited, if we have traversed, if we have exhaust all the possibility, starting from this one, wherever this first one we started, if we have traversed all the island, marked them as 0, then we got one island, right? But as we visit that, we don't want to traverse a 0th element, right? We only want to traverse if it's 1. So every time we check, hey, if grid of I j equal to 0, then also I don't care. If grid ij equal to 0, okay, well, this can give us out of bounds, so better keep it at the last, right? Since before coming to that, we'll already have our indexes checked, so that's good for us. So we'll return this, and instead of this DFS call, let's say, hey, I'm gonna say DFS grid current I, whatever we have, current j, right? If we have that, we're gonna increment and so forth and so on. Let's try to run it. Okay, my bad. What did I do wrong? Okay, let me see, there must be an error here.